When we sketching graph of a function, we are using derivatives, right? Now, I come up a very good picture to help us sketch the curve by using derivatives. Now, this shape looks like a bowl, that holds the water, therefore is positive. Second derivative is a positive. This is umbrella, does not hold water, therefore the second derivative is a negative. So first derivative is second derivative is positive. The curve looks like this. The second derivative is negative. The curve of a function looks like this. Now this is a decreasing, therefore the first derivative is negative. This is increasing. The first derivative is positive. And this is the first derivative is 0. And this is the minimum. This is increasing. First derivative is positive. This is decreasing. First derivative is negative. This is the first derivative 0, which is the maximum. See, these two pictures summarizes as many pieces of information. If a function, the first derivative is negative, second derivative is positive, the shape of the curve looks like this. If the function first derivative is positive, second derivative is positive, the shape of the curve looks like this. If the first derivative is 0, second derivative is positive, this is the minimum value. Well, here the same thing. First derivative is positive, second derivative is negative, this is the shape. First derivative is negative, second derivative is negative, this is the shape. First derivative is 0, second derivative is negative, it's the maximum value. So these two pictures summarizes all the information we need. Not all information, but many pieces of information we need in sketching the graph. Okay. Now let me have an example. Okay, this is the function we want to sketch. Now, first you find the derivative, right? The derivative. First derivative. Now, I'm not waste your time to show how to find the derivative. Suppose you know how to find the basic derivatives, right? So this is equal to e to the power of e to the negative x minus 2 minus x. We differentiate this function with respect to x, and we are using product rule and the chain rule. So after that, you simplify. This is the derivative. Now then, x equal to 0. The derivative of y is equal to 0. Then you get two values, right? X is equal to 0 and 2. Okay. Very good. Now the second derivative, well, the derivative of this one, right? The derivative of this, and then we simplify. The result is e to the power of negative x 2 minus 4x plus x squared. Okay. Then we find when second derivative is 0, then x equal to this one equal to x, right? This x equal to approximately 0.586 or 3.414. Okay, so we find some the critical points, these two and these two. We find the critical points. When you sketch the graph, you're looking for the critical points, right? Now, then we find these f of 0 is 0, right? F of 2 is equal to 0.5413. F of 0.586, this is equal to 1.9112. And f of 3.414 is equal to 0.38357. Well, these just preparing for our curve sketching, okay? Simply means the calculated value after you find the critical points. Now, the main job is that we have to sketch the curve based on those critical points, the information we have, right? Now, there's one more information that when x approaches to infinity, y is approaching to 0. So we have asymptote. So the limit x goes to infinity, this x squared minus e to the x, right? This one goes to 0. So we have an asymptote, y equal to 0. Okay. Now then we collect all these pieces of information. I make a table to summarize those these information. We have four. Okay. The first one is 0. Yeah, 0. The second one is a 0.586. Then 2, right? Then 3.414. We have 4 points, critical points, and we divide the whole interval into 4 by these 4 points. Now let me write small. This one is from minus infinity to 0. This one is from 0 to 0.586. I hope you see that. This was from 0.586 to 2. That's the interval. Huh? This was 2 to 3.414. This was from 3.414 to positive infinity. See what I'm saying, that we have 4 critical points. We divide the whole interval from minus infinity to positive infinity into 4 sub-intervals. Then the main part of a sketching job is that we are using these 2 pictures. You know. First, in this interval, the first derivative is this one, right? And you pick up a value, you put into the first derivative, and it come up negative. And at the 0 is 0. and then you pick up a value between 0 to 0.586, any number, you put it in the value of the function, and you get positive. And you pick up a value, you put it in the first derivative, it's still positive. This is also positive. This is 0, as we did. Then you pick up a value, in this interval, put in the first derivative, and this is negative. And this is a point, right? Put it there, it's still negative. And pick up a value then put it into the first derivative is a negative. And similarly, we pick up a value here, put in the second derivative. That is negative. This, you put it here. Yes. We pick up a value, put the second derivative. This one is positive, sorry. And this is, put a 0 here, is positive. Pick up a value, put a second derivative is positive. And pick up a value here, then you get a 0. And pick up value here is a negative. And pick up a value 2 is a negative. And pick up a value here, put in a second derivative, is a negative. And this value, second derivative, is a 0. No. Put here is a positive. Let me check it again. It's positive. Yeah. Second derivative. Second derivative is 0. This is 0. That's right. These two values 0. Okay. Then we can sketch the curve based on this. Second derivative positive. First derivative is negative, so this is a shape. This is the shape. Second derivative is positive. First derivative is 0. That is the minimum value. Second derivative is positive, and the first derivative is positive. So this is a shape. Okay. And the second derivative is a negative. First derivative is positive. That is the shape. This is the shape. Second derivative is positive, is negative. First derivative is a negative, so that's the shape. Second derivative is a positive. First derivative is negative, so that's the shape. Okay. When x approaches the infinity, y is 0. That's the asymptote. So, after having these information of the curvature, the shape of the curve, we can sketch now. From infinity to 0, this shape. So that's the shape, right? See? This is the shape from infinity to 0. And then come to the point 0. 0 is 0, right? Yeah. Then next point, we have to locate a point, right? 0, 0 is here. This is 0, 0. Well, I have to choose. This is 1. This is 2. This is 3. Okay. Then this is 0.1. This is 0.2. 0.3. 0.4. 0.5. Okay, now 0, 0, right? And 0.586 somewhere here. While this is 0 point. So this point corresponding to 1 point something, 0.19 somewhere here. So this point is this. And next point is 2, right? Yeah, 2 corresponding to 0.5 something, 0.54. Okay. Next point. Now let me write down this one. This 0.5413. The 0 is 0. 0 is 0. This is 0.19112. And this, when x is 3 something, this is 0.3835. Then when x equal to 3.4 something here, this is 0.38 somewhere here. So okay, these are 4 critical points. Now from 0 to this, from 0 to this point, from 0 to this point is this shape. The curve looks like this. This shape. Then from this point to 2 is this shape. So this shape. Then from 2 to 3.4, from 2 to this point, the curve is look like this shape. And from 3.47 onward is this shape. And with y equal to 0 is asymptote. So it looks like this. So that will be the curve of this function. Now, every section of the shape of the curve are summarized in this table, and the summary is coming from the positive or negative, the derivatives. Okay. Well, I have a series of 8 videos talking about the curve sketching using this type of techniques. If you're interested, you can find them. Okay. Thank you for your watching.